Example 5. Given a function f(x), x times x minus 2 square, find all the maximum and minimum points of f(x) by using second derivative test. Step 1 here involves finding critical points of the function f(x). For that, function f(x), which is x times x minus 2 to the power of 2, need to be differentiated using product rule. So product rule of this function will be x times derivative of the second function, which is 2 times x minus 2 to the power of 1 times by 1, and plus with keeping x minus 2 square and times with derivative of this function x, which is 1. Simplify this further will be 2x x minus 2 plus x minus 2 to the power of 2. We are able to see x minus 2 appears in both expressions. Therefore, x minus 2 to the power of 1 can be factored out, and we will have 2x plus x minus 2. Further simplification will give us x minus 2 and 3x minus 2. Once we have the f prime of x for the function f(x), we need to equate this function to be equivalent to 0 in order to find the critical numbers. Therefore, x minus 2 times 3x minus 2 must be written to equivalent to 0. From here, we will be able to get x equals to 2 and 3x minus 2 equals to 0, and this will give us x equals to 2 over 3. So these are the critical numbers that we obtain for this question. For every x obtained in this question, we need to find the corresponding y values. Therefore, when x equals to 2, f of 2 is calculated as 0. When x equals to 2 over 3, f of 2 over 3 is calculated as 32 over 27. From here, matching values of x and y's as a coordinate form will give us coordinate 2, 0 and coordinate 2 over 3, 32 over 27 as stationary points of this function f(x). In this step 2, we will perform second derivative test. For that, we will start this f prime of x, which was x minus 2 times 3x minus 2. This function can be expanded to 3x square minus 8x plus 4. Second derivative test can be obtained by having the second derivative of this function, which is 6x minus 8. For every critical number obtained, say we start with x equals to 2, f a double prime at this point 2 will be 6 times 2 minus 8, which is equivalent to 4. And we notice that this number is positive, greater than 0. For critical number x equals to 2 over 3, f a double prime at this point 2 over 3 will be 6 times 2 over 3 minus 8. This will give us negative 4, which is less than 0, a negative number. Finally, we are in step 3 to make a conclusion. As we seen in step 2, for the critical number x equals to 2, the f double prime of 2 is a positive number. When this value is greater than 0, a positive number, we will say the coordinate involved, which is 2, 0, is a minimum point. And for the critical number x equals to 2 over 3, we observe that the f double prime of this point 2 over 3 is a negative number which is less than 0. So when this value is a negative value, coordinate involved this critical number will be called as a maximum point. Therefore, coordinate 2 over 3, 32 over 27 is decided as a maximum point. So we have two local extrema here. One is a minimum point and the other one is a maximum point.